random citizen.
This is me, Eloisa Bisanson.
And I'm Isabella Hernandez. And we're gonna present to you
Chemical formulas.
Chemical formulas. A chemical formula is a combination of symbols that represent the composition of a compound. It states what atoms are present and the number of atoms of each element in the compound.
Chemical formulas are used to supply infos about types and special arrangement of bonds in chemicals, though not necessarily specify the exact measurement.
Now, how does it help the scientific community? It helps the scientific community by naming compounds mainly. Without it, many questions will be asked. Example, what elements compose glucose? Carbon, hydrogen, and oxygen. Now, how many of each element is needed? 6, 12, and 6. Pretty handy, right?
To master chemical formulas may not be easy if you lack the skills of memorizing and analyzing and the will to study. So, we need to know the names of the elements, its symbols, the uses of its symbols, and the oxidation numbers.
Now for the basics. Names of elements. Most elements are named depending on who discovered them, but some elements that were known since ancient times are hard to get the background on. Gold and tin, for example, were discovered during ancient days. But that's your history teacher's job to tell you that. Elements are most commonly named after their characteristics and properties. Nitrogen comes from the Greek words nitron and genes. Next, there's the place where it's discovered. Hafnium was discovered in Copenhagen, Denmark. Latin for Copenhagen is hafnia. After that, there's the source or the name of the mineral that it was found in. For example, boron was found in a mineral called borax, and boron was just as black as carbon. So, borax plus carbon, boron. Last, there are the names to honor a place or a person. Curium was named to honor Marie and Pierre Curie for their work. Rutherfordium was named after Ernest Rutherford, and some other examples in the periodic table.
Element symbols are basically derived from their names. Scientists throughout the world have agreed to give each element its respective symbols. Thanks to J.J. Berzelius, a Swedish chemist, for creating the modern symbols for elements we use today. He was the first to give elements symbols corresponding to the first letters of their names. In case of two elements beginning the exact same letters, the second letter or an important letter is given. Just like sulfur is S and selenium is S, lowercase e. In some cases, the Latin name of the element was used, just like gold having Au as its symbol from its Latin name aurum.
Hey, but what about the 113th to 118th element?
Oh, it's because of the IUPAC, the International Union of Pure and Applied Chemistry. The mix of Latin and Greek stamps representing the atomic numbers of the elements are used for both name and symbols.
What is an oxidation number? An oxidation number is the charge on a monoatomic ion. It is represented by a positive or negative number, or just a plus and minus sign if the oxidation number is 1. To determine the ratio of the elements in a compound, add the oxidation numbers. And if the result is 0, then you'll know that the formula is written correctly. Ionic compounds are compounds composed of ions to... But it's... Shut up, Cal! I'm gonna recording! Ionic compounds are compounds composed of ions, to put it simply. One important note. When writing a name of a compound, the positive ion always goes first, okay? A monoatomic ion is a single atom that takes on a charge, while a polyatomic ion is an ion that's composed of more than one atom.
How to write the formula.
For example, take the elements calcium and bromine. The sum of the charges has to be 0. 2 boron atoms are needed to balance one calcium atom's charge. Having 2 atoms of bromine makes it charged to negative to balance the charge of calcium.
For example, take aluminum and a sulfate ion. The sum of the charges has to be 0. To do that, we must find the least common multiple of the charges of the ions. For 3 and 2, it would be 6. 6 divided by 3 is 2, and 6 divided by 2 is 3. 2 aluminum ions and 3 sulfate ions are required to balance the equation. Since a sulfate ion, SO4, is a polyatomic ion, it needs to be placed in a parenthesis to indicate that 3 of the polyatomic ions are needed.
Elements also combine into another way. Neutral atoms combine to form the metal particles called molecules.
Compounds formed from molecules are called molecular compounds.
Some compounds have both a common name and a chemical name. For example, acetylsalicylic acid is the chemical name for aspirin. Tongue twisting, right?
Acetylistic
Wait,
acid.
you forgot your head.
How does this help?
Binary compounds contain only 2 elements. To name a binary compound, first write the name of the element having the positive charge. Then add the name of the negative one.
The negative element should end with "ide." For example, the compound forms by aluminum and nitrogen. With the formula Aln, boom, it's aluminum nitride. Here are some more examples.
Inorganic compounds. They are named the same way binary compounds are named, but the suffix has not changed. Organic compounds. The simplest group of organic compounds is the hydrocarbons. Carbon and hydrogen play a major role here, because hydrocarbons are made of just hydrogen and carbon. To name these compounds, you have to count the number of carbon atoms there are in a carbon chain or ring. The prefixes that will be used are shown here. There are suffixes added to say how the chains are linked, but that will be discussed in organic chemistry, which will be discussed by my fellow teachers. For now, we use the suffix "ane." If the atoms are linked in a ring, then the prefix cyclo is put before the prefixes that I just showed to you in the graph. For example, in naming, we have this figure. It's called cyclopentane. Count the number of carbons. 1, 2, 3, 4, 5. So we use the prefix pent, and since it's in a ring, we call it cyclopentane. Molecular formula. This is how we write formulas that exist as molecules. This formula states exactly how many atoms there are in a molecule. For example, hydrogen peroxide. Two atoms of hydrogen and 2 atoms of oxygen. Empirical formula. Under this formula, the simplest way for a formula to be expressed is going to be used. For example, the hydrogen peroxide here in the empirical formula form will be expressed in this way. But remember, it still has to have the same ratio of atoms present. Coefficients. These things show the amount of a compound present during a certain time. For example, if you want to say that there are 2 CO2 or carbon dioxide molecules present, you have to write it like this. It expresses the number of carbon dioxide molecules there are.
Alright, random citizen, this is all we have to teach you.
Goodbye! Oh wait, we forgot something.
Alright! Here a quiz.